Page 3 of Applications of Integration. We are trying to find the area between the x-axis and the part of this parabola which goes below the x-axis. To do that, we kind of need to figure out the roots or the zeros of this quadratic. Just to maybe take this opportunity to teach you about something that your calculator does that's pretty cool. You go to PolySMLT, you can find the roots using the PolyRoot Finder. So you go into PolyRoot Finder and you give it the coefficients. First you need to say it's a quadratic, so you say order 2 because the 2 here is the order. Then you give it the three coefficients here, the x squared coefficient, the x coefficient, and the constant term. So you give it a 3, you give it a -8, and you give it a 4. And then you say solve, and it'll give you the two zeros. And one of the zeros is 2/3, and one of the zeros is 2. So if we were to draw a picture of this, it would kind of look like this. It would be 2/3 and 2. And then the parabola is going to go below the x-axis there. And then we're going to find this area. So we would write it by writing, let's see, the integral from 2/3 to 2 of the region, the x-axis, let's say that's like 0 minus the parabola, which is 3x squared minus 8x plus 4 dx. And so if we took the integral of that, it would be x cubed divided by 3 times 3, which is x cubed, minus 8x squared divided by 2 plus 4x integrated from 2 to the, oops, and that's all negative, right? There's negative here. Integrated from 2/3 to 2. Okay, so let's see. First we're going to substitute 2 in there. So it'll be -8 minus, and then 2 squared is 4. Times 8 is 32, divided by 2 is 16, minus 16, plus 8. And wow, that just becomes 0, doesn't it? Minus, and then now we're going to put 2/3. So it's a minus of negative, so it'll be plus. We're going to put 2/3 cubed, which would be 8 over 27. Minus 8, and then 2 squared would be 4, divided by 9, plus 8 divided by 3. Wow, that's a big mess, isn't it? So so that gives us 8 over 27 minus 16 divided by 9. 8 over 27 minus 16 divided by 9 plus 8/3. And I think we can put everything over 27. So I have 8 minus, and then it would be 16 times 3, which would be 48. And then 8 times 9, which would be 72. 72 plus 8 would be 80, minus 48 would be 32. So the answer is 32 divided by 27. Okay? Let me just shrink that a little bit. Took up an awful lot of space. Okay. Letter E. Y equals x cubed minus 4x, the x-axis, and x equals 1 and x equals 2. Oh, how nice. They told us what the zeros are. Now, let's see. So we're going to take the integral from 1 to 2 of x cubed minus 4x. And, oops, let me just check one thing, because I don't know if this function is above the x-axis or below the x-axis at this point. So how about if I put in like 1.5? 1.5 is right between 1 and 2. So I'm going to put 1.5 in here, and then I'm going to see what it equals to see if the polynomial is above or below. So 1.5 cubed minus 4x, minus 4 times 1.5. And it's a negative number, so actually it is, it will look kind of like this. Between 1 and 2, the graph goes below the x-axis. So I want to put a, since I'm going to get a negative number here for the area, I'm going to put a negative here to make it unnegative, okay, and positive. Okay, so I'm going to take the integral, and it's going to be x to the 4th divided by 4, got a negative on the outside of this, minus 4x squared over 2, and I'm going to evaluate this integral from 1 to 2. So first I put 2 in here. I'm going to get negative 2 to the 4th, which is 16 divided by 4, which is 4, minus, and then I have 2 squared, which is 4 times 4, 16 divided by 2 is 8. And then I got a minus of a negative, and then I'm going to put in 1 into x to the 4th over 4, and then I'm going to put 1 into negative 4x squared over 2, and I'm going to get negative 2. So now I got a 4 minus 8, which is negative 4, negative of that, which is positive 4, and then I have a 1/4 minus 2, which is negative 1.75. Negative 1.75. So the answer is equal to a positive 2.25. Okay. G. I'm going to find the area between one arch of sine squared and the x-axis. Sine squared. So sine squared, or you remember what sine looks like? Sine just looks like this, right? And this point here is pi, and this point here is 2 pi. What does sine squared look like? Well, sine squared is just like, it's also a sine wave, but it's always positive. It looks kind of like that. So one arch of sine squared is like this part here. So one arch of sine squared goes from 0 to pi. So we're going to have the integral from 0 to pi of sine squared x dx. So it'll be, we can rewrite sine squared as a, so remember that we cannot take the integral of sine squared. It's a little bit too complicated. So what we're going to do is we are going to put in the double angle identity. So we're going to have 1/2 minus 1/2 cosine 2x, substitute in for sine squared, and now we can take the integral for this. Oops, and I made a mistake here. We haven't taken the integral yet. We've only substituted in. So we're going to substitute in here. We're going to take the integral from 0 to pi, and the let's see, that'll turn into 1/2 x minus, and it's what is the integral of cosine 2x? It would be sine 2x divided by 2, and then we'll evaluate that from 0 to pi. Does that work out? Cosine 2x, x chain rule. Yeah, I think that works out. So let's evaluate this now. So we'll have first we'll substitute pi in. So we'll have 1/2 pi minus 1 over 2 sine 2 pi, which is just 0, so the whole thing's just going to disappear. And then we're going to subtract the value when we plug in 0 for everything. So it'll be 0 minus, and then sine of 0 is just 0 again. So in the end, we're going to get just pi over 2. Okay? All right. Number 3, consider the graphs y equals x minus 3 and y equals x squared minus 3x. Sketch the graphs on the same set of axes and find the coordinates of the points where the graphs meet. I'm really sorry I didn't give you graph paper on this. Let's see. So, let's sketch some graph paper here. So x minus 3 is a diagonal line that goes through the y-intercept of 3. And y equals x squared minus 3x is a parabola, and the vertex is at, not sure, but let's see. When you put in x equals 0, you get 0. When you put x equals 1, you get 1 minus 3, which is negative 2. When you put x equals 2, you get 4 minus 6, which is also negative 2. And when you put in 3, you get 9 minus 9, which is 0. So it looks like you have a parabola which is lined up here. The vertex is kind of at x equals 1.5. Right there, in the middle. Okay, so we have sketched the graphs on the same set of axes. And then it says, find the coordinates of the point where the graphs meet. Okay, that's not a trivial problem. Okay, then we're going to find the area enclosed by the graph. So this area in here. Now, there's nothing magic about finding the intersection points between these two. You've done it many times in middle school, and I'm going to just show you how to do it on the calculator because maybe you haven't done it with the calculator too much. So we're going to just put in the two equations here, x minus 3, and the other equation is x squared minus 3x, x squared minus 3x. And then we graph the two, and we should get something like we just drew here. Yeah, oh man, look what I did. I made a mistake. It's not x, it doesn't go through y equals 3, it goes through y equals negative 3, right? So, it's kind of good that we did this with the calculator so that I could see my mistake then. So, actually, it goes kind of like that. And then I can find my two intersection points using second calc intersect and first curve, second curve. Yeah, I say yes to both of those because we already know that there's only two curves in here. And then that says guess, so we'll just guess that one. So one of the points is 1 comma negative 2. That's that one there. 1 comma negative 2. And the other one is this one here. Let's try to find that one. We'll do second, calc, intersect, and then first curve, yes, second curve, yes. And then to guess, we're going to move it closer to the second intersection. We hit enter, and the other section is 3 comma 0. Oh, actually it intersects right here, I guess, right here at the x-intercept, or at the x-axis. Okay. Now we're going to find the area enclosed by taking the integral from 1 to 3 of the function x minus 3 minus x squared minus 3x. And the reason why we put x minus 3 first is because it's the one that's on top. We put the one that's on top first. And so now we could, just with algebra, combine some of these terms. Like, for example, the x could go together with the negative minus 3x. That would be 4x, right? and then the negative x squared we'll put out front, and then the 3, the negative 3 would come finally at the end. So we're going to take the integral of this now. So we'll have negative x cubed over 3 plus 4x squared divided by 2, and then minus 3x, and we are going to evaluate it from 1 to 3. And let's make this a little smaller. So if we put 3 in here, then we're going to get negative 27 divided by 3, which is negative 9. And then we're going to put 3 squared, which is 9 times 4 divided by 2, which is 18. And then we're going to put negative 3 times 3, which is negative 9. And then we're going to subtract the whole thing evaluated at x equals 1. So that would be minus a negative 1/3 plus a 2 minus a 3. And so you can see that this one here just goes to 0, right? 18 minus 9 is just 0. And then this one here, let's see, 2 minus 3 is negative 1 minus 1/3, which would be negative 4/3. Then we take the negative of that, and it would be positive 4/3. So the answer is positive 4/3. Number 4, determine the area of the region enclosed by y equals square root of x and y equals x squared. This is not such a bad one to graph. It would be y equals square root of x would be kind of like that. Y equals x squared would be like that, right? Parabola. And so the region we're looking at is right there, like a petal. And we could see that this goes from 0 to 1. Right, because they both have a point in common, 0, 0 and 1, 1. So we're going to take the integral from 0 to 1 of the square root of x minus the x squared function. So first we're going to take the derivative of that. Remember that square root of x is the same thing as x to the 1/2. So we're going to take the integral of that. So when we take the integral of x to the 1/2, it's just x to the 3/2 times 1 over 3/2, which is 2/3. And then the integral of x squared is x cubed over 3. And we just need to evaluate this from 0 to 1. So first we plug in 1 there, and we get 2/3 minus 1/3. And then we plug in 0, and then we get just 0. And then basically the answer then is 1/3. Okay. Last one for this page, 5a. On the same set of axes, graph y equals e to the x minus 1 and y equals 2 minus 2 e to the minus x, showing axes, intercepts, and asymptotes. Let's see. E to the x minus 1. So e to the x, remember, kind of graphs like starts at 1, and then it goes to 2.71, and then it goes up, right? Now, since it's e to the x minus 1, it's going to be 1 position lower than that. So it's going to be start at 0, and it's going to go to 1.71. And then it's going to have an asymptote here at negative 1. And then it's going to go up here at about 7 something. Okay, so that's that function there. And the other function we're going to graph is 2 minus 2 e to the negative x. And so this function has an asymptote at x equals 2. And actually it goes down. Let's plug in a few points. So like we're going to put in x equals 0, it'll be 2 minus 2, which would be 0. So it actually starts there. And then if we put 1 in there, it will be 2 minus 2 e to the negative 1. And that's a little bit hard to calculate, so we'll do negative 1 instead. If we put x equals negative 1, we'll get 2 minus 2 e to the first. So that would be 2 minus, so 2.71, which is e, times 2 is about 5.4. So it would be 2 minus 5.4 would be like negative 3.54. Wow. It'd be like, it'd be about here. Okay, and then it would kind of go like that, I think. Alright, so find algebraically the points of intersection of these two, and I don't know if I drew this right. Let me graph it on the calculator just to see if I drew this right. So e to the x minus 2, e to the x minus 2. What is with the calculator thing? It's plus minus 1. And then the next line is going to be 2 minus 2 e to the negative x I should have just cleared everything, huh? 2 minus 2 e to the negative x. Now I'm going to graph this. So there's my blue curve. And then where's my purple? Oh, there's my purple curve. So I'm going to zoom in a little bit because I can't really see anything there. So I'm going to put negative 4, positive 4. Now let's graph it. Yeah, so there is, I can't really see where the points of intersection are. Maybe I can do the y points a little bit zoomed in here. Okay. And then I'm going to find the region enclosed by these two curves. Ooh, so it looks like it intersects at 0, 0 and maybe 1, 1. Let's test that out. So if we put 1 in each of these, we get e minus 1 and 2 minus, no, it doesn't look like that. So let's see what one of the points, intersection point 0, 0. What's the other intersection point? We'll find it using the calculator. We'll go second calc, intersect, first curve, yes, second curve, yes. And then we're not going to put guess x 0, 0, 0. We're going to put something a little bit closer to here. because we want that point. Ah, there it is. So it was 0.693, comma 1 is one of the intersection points, and that's kind of a special number when we talk about E, and we'll see why. So we're going to do this integration, and we're going to take the blue curve, which is e to the x minus 1, and we're going to subtract the purple curve, which is 2 minus 2e to the negative x, and we're going to integrate from 0 to 0.693. And let's see why that is a special number for the calculator. So we'll put second e to the x, and then we're going to put 0.693, and we're going to see what we get. Oh, because it gives us 2. So that's a special number because it gives us 2 when we plug it into here. So we're going to take the integral of this expression here, but to take the integral we need to simplify it first. Because look, negative 1 minus 2, those can be combined, right? So we're going to have e to the x, negative 1 minus 2, which is negative 3, and then minus a negative 2e to the negative x is just going to be plus 2e to the negative x. And we're integrating from 0 to 0.693, right? And we are going to find the integral of this, expression. So it's going to be e to the x. The integral of e to the x is e to the x. Integral of negative 3 is negative 3x. The integral of 2e to the negative x is just negative 2e to the negative x. And we're going to integrate from 0 to 0.693. And we are going to put 0.693 in here. And remember, e to the 0.693 is 2, so e to the 0.693 is going to be 2 minus 3 times 0.693 minus, and then we have 2e to the negative 0.693. I wonder what that is. Is that a special number too? What's that? Ooh, it's 0.5. That's pretty cool. So that would be negative 2 times 0.5. And then now we're going to subtract all these values with 0 plugged in. So e to the 0 is 1, minus 3 to the 0 is 0, and e to the negative 0 is 1, so it's minus 2. So 1 minus 2 is negative 1, minus a negative 1 is positive 1. This is a minus negative 1, so it's 1 minus 1, those cancel each other out too. And so we just end up with a 2 minus 3 times 0.693. So let's do that. 2 minus 3 times 0.693. And that gives us negative 0.079. Negative 0.079. By the way, I was just figuring out why I got a negative number, and the reason is because I put the blue function on top, and I put the purple function on the bottom. But if you think about it, like the blue function is actually crossing the purple function, and so like we're actually looking at this region here, which is the purple function is on top. So I put it in the exact wrong order, and that's why the answer came out to be negative 0.079. Actually, the answer should be positive 0.079, right? Okay, and that's it for page 3.